All right, welcome to the Explainer. Today, we are putting on our data detective hats. Seriously, we've got this case that's just full of numbers, thousands and thousands of credit card customers. And our one mission? It's to find the hidden groups that are just lurking inside all that data. So just imagine for a second that you're a credit card company. You've got this absolutely massive amount of customer information, right? What they buy, how often, how much they're spending. I mean, it's a total gold mine of data. But here's the catch. Right now, it just looks like a giant, intimidating wall of numbers. So how do you actually find the meaningful groups in there? You know, the big spenders, the cautious savers, maybe even the people who are about to leave. Well, that's the mystery we're going to try and solve today.
You know, every good investigation, it starts with a clue. And for us, the clue is this, the data itself. Yeah, at first glance, it just looks like a sea of numbers. But if you look closer, each row is a real person, and every single column is a piece of their financial story. Our job? It's to find those patterns, those hidden stories that connect all of them.
Okay, so this gets us right to the heart of our mystery. How do we take this mountain of raw data and turn it into something a business can actually use? How do we find the who behind the what?
Really, the whole point of this entire exercise is transformation. We're trying to turn that raw, kind of confusing data you see over there on the left into these clear, actionable groups on the right. See, instead of just a jumble of numbers, we want labels, things like high-value shoppers or potential premium card candidates. These are names that actually tell a story and can help you figure out a strategy.
Now, to crack a case this complex, we're going to need a special tool. We can't just eyeball this thing, right? No way. We need an algorithm, one that's specifically designed to find these natural little crowds and communities hiding in a huge sea of data points.
So the technique we're using is called clustering. And our specific tool? Well, it's an algorithm with a pretty technical-sounding name, DBSCAN. But don't worry about the full name. What's really important is what it does. Just think of it like a digital detective, okay? It's super good at finding these crowded little neighborhoods of similar customers. And this is key, it's also great at spotting the loners, the ones who don't really belong to any crowd.
All right, let's get into it. Before we can even think about running our analysis, any good detective knows you have to prep the evidence. And I mean meticulously. You just can't throw raw data at a problem and expect good results. So our very first step is to, well, clean up the crime scene, so to speak. We got to get rid of anything that could throw us off the scent. For example, that cust ID column? Gone. It's just a label, like a name, and it doesn't tell us anything useful about a customer's behavior. We also patch up any holes in our evidence, fill in those missing values. And just like that, our data is clean and ready for the next step. But now we hit a bit of a roadblock. See, each customer is defined by a whole bunch of different things. Their balance, their purchases, cash advances, you name it. This is what we call high-dimensional data. And the problem is, it's pretty much impossible to plot on a simple 2D chart that our brains can actually make sense of. So, to solve this little puzzle, we bring in another tool, Principal Component Analysis, or PCA for short. Now, it's not magic, but it's pretty close. It's a super clever way to take all those different columns of data and kind of squish them down into two new super columns that still capture the most important stuff. It's kind of like creating a shadow of a complex 3D object on a 2D wall. Yeah, you lose some of the fine detail, but you can see the overall shape much, much more clearly. Okay, with our evidence all prepped and our views simplified, it is finally time to run the analysis. Let's unleash our cluster detective and see what it's managed to find. And now for the moment of truth. We're going to let DBSCAN loose on our data. We just have to give it a couple of instructions, kind of like setting the focus on a camera. First, we tell it how close two customers need to be considered neighbors. And second, we tell it how many neighbors a customer needs before we start calling it part of a crowd. With those two settings locked in, we just let the algorithm do its thing. So, after sifting through all of those data points, what did our digital detective actually uncover for us? Well, check this out. The algorithm identified 3 distinct clusters. That's 3 separate groups of customers who all seem to share similar behaviors. But here's something really cool about DBSCAN. Something that a lot of other clustering algorithms don't do. It doesn't try to force every single customer into a group. Nope. It has a special category for the oddballs, the customers who are just marching to the beat of their own drum. And it found 43 of them. 43 noise points, or what we call outliers.
These are customers whose behavior is so unique that they just don't fit into any of the three main groups. Now, these folks could be incredibly valuable or maybe even problematic customers. And the key thing is, now we know exactly who they are.
And wow, this chart just brilliantly illustrates our findings. After all that prep, all that analysis, here they are. The hidden customer groups finally brought out into the light on a chart that we can actually understand.
So let's break down what we're looking at here. That massive sea of yellow dots, that's your main general customer base. But tucked inside, you see those two much smaller, tighter clusters in green and blue? Those are really distinct niche groups. And then, scattered all around the edges, you see the red dots. And yep, those are our 43 unique outliers.
But wait, hold on a second. A good data detective never takes the first result at face value. I mean, sure, we found something that looks like groups, but we have to ask ourselves a really critical question before we start celebrating. So, we found clusters. Fantastic. But how well defined are they really? Are the lines between these groups sharp and clear, or are they all fuzzy and overlapping? You have to remember, just because an algorithm spits out an answer doesn't automatically mean it's a good one.
To figure that out, we need a way to actually score our results, and for that, we use a metric called the silhouette score. The easiest way to think of it is like a report card for our clustering job. For every single customer, it asks two simple questions. 1, how similar are you to your own group? And 2, how different are you from the group that's closest to you? Now, a score close to +1, that's like an A+. It means our groups are tight and really well separated. A score near 0 is more like a C. The groups are kind of fuzzy and overlapping.
And our score is, drumroll please, negative 0.178. That is definitely not what we wanted to see.
Okay, so a negative score, that is a big red flag. It's basically telling us that, on average, our customers are actually more similar to people in other groups than to the people in their own group. The lines between our segments are just completely blurred. So, what does this mean? Did we fail? No, not at all. This is an absolutely crucial part of the process. This result tells us that our initial assumptions, or hey, maybe the settings we gave our algorithm, were just wrong. This isn't a dead end, it's a brand new clue, one that tells us we need to go back to the drawing board and rethink our approach.
So after all that, what have we actually learned from this investigation? Let's put all the pieces of the puzzle together.
We've really gone through the entire investigative process, haven't we? We started with the big mystery of all that raw data. Then we prepped our evidence, cleaning it up and using PCA. We ran our DBSCAN analysis and got that super exciting reveal, 3 groups and 43 outliers. But then came the most important step of all, the reality check. And that showed us that our findings, well, they weren't quite as clear-cut as we first hoped.
This whole process really shows that finding patterns in data is incredibly powerful. But, and this is the big takeaway, understanding the limits of your tools and critically evaluating your results, that is the key to true insight. It proves that data science isn't just about getting an answer, it's about knowing how much you can actually trust that answer. And that kind of leaves us to wonder, what other hidden patterns are just waiting to be discovered and verified in the data all around us?